Now, I wanted to say something about the density of people here, because the National Park Service flew a few times in the morning and a few times in the afternoon, and there was a gap in the middle between 11:30 and almost 3 o'clock. And this gap was due to the fact that there was an emergency. A lady and her son had to be taken to a hospital. And the regulations of the National Park Service say that if there is an emergency, they stop doing what they are doing and tend to the emergency. Now, the Million Man March organizers have asserted that the highest peak of attendance at the march was during this time, which means that it is quite possible that there are no National Park Service photographs that were taken of the peak attendance during the march, meaning that whatever numbers that anybody can come up with from this information, the actual number might actually be bigger because the peak time may not have been photographed. And we know now that the photographs were not taken because of an emergency, and these are the rules for the National Park Service. If there is an emergency, they stop and they go ahead and do what they are doing. Now, what happens here that we have a picture like this, and what do we do with it? As I said, when the images that we received from the National Park Service were taken at a great angle, and you can see this, the distortion in the view, because you're looking from a great angle like that. So to be able to study a photograph and to be able to measure distances and so on, we have to fix this oblique view and make it into a vertical view. The way to do this with the help of the computer is the fact that we can pick up specific sites of places that we can mark on this image or the photograph and transfer these points and register them on top of the same points in the vertical view that we had taken from the Geological Survey photo map. So we can take the corners of the Capitol building and the corners of the Capitol building as seen from here and transfer them onto this, and then you take many other points. I think Abdelkader Abul Qasim had, in this particular view, had taken, one of my colleagues here had taken something like 39 points over this photograph to be able to transfer the oblique view into a vertical view. And now we can look at it here as if we have moved the helicopter from way away from the cloud into almost above the cloud. So you can see here that this is a photograph of the crowd as if we're taking it vertically. So we have removed the obliquity and looked at the picture straight down. The reason for this is the fact that you'd want to measure distances here, and wherever you would be on a grid, you would be equidistant. So the length of a ruler in here would equal the length of a ruler here and would equal the length of a ruler right here. When this is accomplished, then we'd look at the images and see how can we make an estimation of the numbers. In places where the crowds are dispersed, where there are spaces between the members of the crowd, we can actually enlarge the view and click on each individual and get exact numbers. Now, this was done by one of our graduate students who actually has been working on measuring sand dunes in the desert of Kuwait, because we wanted to see how many sand dunes were developed in Kuwait since the Gulf War. Because of the disturbance to the desert surface, new dunes formed, and wanted to see how many dunes formed and where did they form. So you can actually enlarge a satellite image of a chunk of the desert of Kuwait and tag each and every dune to count it. So it's almost the same methodology. Instead of working from a satellite image, we're working from an aircraft image. And then instead of looking at individual dunes, you're looking at human beings. And you can actually count this number when the numbers are dispersed, or the crowds are dispersed. When the crowd is very densely packed, you cannot do this, because you do not see individuals. Shadows hide individuals, and two individuals become one, and so on, because they are densely packed. So you have to estimate. This estimation has to be based on a number that you think exists over a unit area. As I said, we've been working with the number of 1 square meter. So when we take this area in here, we estimated that 6 people can stand in an area that is 1 meter square. So this will be the densest packing. And I will retract for a minute here to tell you that the National Park Service uses the number of per individual you need 5 square meters. But actually in our calculations we used per individual only 1.5 square feet. So when we say that the densest packing is going to be about 1 meter with 6 individuals, then we can take the area of densest packing, which is the red color right here, where every square meter in this area would have 6 people. The yellow zone right here shows that every square meter in here has only 4 people, and every square area in the blue has 2 people, and so on. You get to 1, and so on. And the areas around the crowd right here, the halo around the crowd right here, is where you have every individual occupies 10 meters square, because it is a dispersed crowd. So you can think of this as a complete pie, and you take each part of a pie with unequal pieces, equal chunks, and then you can calculate the number, and you get for this pie a complete number. For instance, we calculated that from the steps of the Capitol all the way to the end of the reflecting pool, in this one corner of the area that was photographed, there are some 266,000 people. So that was one area. For the rest of the mall, we get the rest of the number. Now that having been accomplished, it is easy then to estimate a total number of people. So we tally then the numbers. Here was as I told you, it was 266,000. Here it was 152, and here that was 127. For instance, on the Washington Monument, there was a crowd right around the Washington Monument at that time, and the time is important because it was we took photographs that were taken between 3:17 p.m. and 3:29 p.m. within that short period of time, because of dynamics of crowds, you do not want to take a photograph of a group at one time and then go to another time, because the crowd would have moved. So we tried to get the crowds at the same time, or coverage of the whole thing. So when you add all of these numbers together, you get to the complete total estimate, which is 837,214, plus minus a lot. And plus minus a lot, that is anywhere really between 15 and 20%. And if you take a number like 837,000 plus minus 20%, you can be as low as 670,000, or as high as just a little over 1 million of people at the mall and the surrounding areas between 3:15 and 3:30 during the day of the Million Man March. And it's important to look at that number of the error number, and the error was really because of the inherent problems in the pictures themselves, and what resulted from this during our estimation and calculation.